Correlation between socio-economic characteristics and housing quality of residential neighborhoods in Akure, Southwest Nigeria. Journal of Contemporary Urban Affairs. 2022, Volume 6, Number 2, pages 217-231. By Drive. Adewale Mukhtar Olayiwola. Drive. Olayinka Akinsumbo Ajala. Department of Geography, Obafemi Awolowo University, Ile-Ife, Nigeria. Keywords: housing quality, socio-economic characteristics, residential neighborhood, sustainable housing delivery system, quality of life in Nigerian. Abstract. There is a general paucity of explanations for the emerging social and spatial changes in the pattern and socio-economic traits of urban residential housing units in Nigeria. Hence, this study examined the spatial pattern of residential neighborhoods, assessed the quality of residential housing units, and evaluated the correlation between the socio-economic position of respondents and housing quality in Akure, Nigeria. Data were derived from the household questionnaire, remotely sensed data, Landsat 8 Oli/Tier, 2021, a Google Earth map, a street map of Akure Township, and personal observations. The study adopted a stepwise sampling technique to select 383 samples from 139,069 heads of households in Akure in 2021. Data were analyzed using percentage distribution, Pearson correlation coefficient, and t-test. Results indicated varying housing qualities across 3 residential zones in Akure, Nigeria. Houses in the low-density residential areas were of better quality than the other residential zones. The quality of houses occupied was influenced by the type of occupation, level of education and average annual income of residents. The study concluded that inadequate housing facilities are fundamental to the observed deteriorating housing qualities in the study area. Therefore, the study suggested improvement of the existing infrastructures and the provision of new ones in the study area. The main contribution of this study is to proffer solutions for a sustainable housing delivery system to facilitate a better quality of life in Nigerian urban centers. 1. Introduction. Housing is consumed with some other items which appear to have no relationship with the land and its uses. One tends to be independent of another. The importance of providing adequate and quality housing in any country cannot be overstressed. Jiboyi, 2010, Zinal et al., 2012, Adewale et al., 2014, Hack et al., 2020. However, the recurrent quality of housing requirements and the interminable craving for good housing appears to confirm the impression that there may be to cope satisfactorily with housing requirements. HSU and Guo. 2006, OOEE and Ogundiran, 2014, Page and Gordon. 2017, Joachim et al., 2018. Thus, to satisfactorily appraise the quality and evaluate the characteristics of a house, it is important to assess the socio-cultural heterogeneity and economic status of the individual property owner. For this study, housing is regarded as dwelling units occupied by households. From this perspective, 3 types of housing can be recognized in urban centers: self-built housing development, private developer-led housing and public housing. Corresponding author. Department of Geography, Obafemi Awolowo University, Ile-Ife, Nigeria. Agoiwayi, Nigeria. Email address, amalayiwala@oauife.edu.ng. Journal of Contemporary Urban Affairs, 6, 2, 217-231/2022. Dr. Adewale Mukhtar Olayiwola and Professor Dr. Olayinka Akinsumbo Ajala 218. Development. Whereas self-built housing is a single family property, the other two types are owned by corporate organizations, which could be private or government. Self-built housing units are the most predominant type of housing units in developing countries. Goff and Yangsun, 2000, Coker et al. 2008, Burkinick, 2017. However, they vary greatly, both in characteristics and qualities. Housing quality can be described as the standard of the residential environment that provides residents with sustainable accessibility, healthy, safe, and beautiful accommodation. Housing quality embraces many factors such as the physical condition of the building and other facilities and services that make living in a particular area conducive. Fakunal et al. 2018, corroborated by Wimalasena et al. 2022, submitted that the quality of housing within any neighborhood should be such that satisfies minimum health and good living standards. Such houses are also required to be affordable to all categories of households. Studies have found that there exists a direct relationship between housing quality and quality of life. Zonghua and Swejun, 2015, Fakunal et al. 2018. Therefore, good housing quality is a basic requirement to guarantee stable communities and social inclusion. Kanadu Ajyemeng, 2001. Wimalasena et al. 2022. Housing is regarded as one of the major factors determining the form of cities. Hence, a major concern in spatial analysis is the geographical distribution and pattern of housing within cities. Residential housing pattern has been the subject of considerable research for many years. The spatial arrangement of housing units in urban environments has been explained in some theoretical frameworks. Burgess, 1925, Hoyt, 1939, Harris and Ullman, 1945. Burgess, 1925, developed the concentric zone model as the first theory to describe the internal structure of a city. The central thesis embedded in Burgess's model is that urban residence conforms to a zonal pattern. Hoyt, 1939, proposed the sector theory wherein he considered direction and distance to explain the outward extension of the residential areas along district radii with new growths on the outer arc of the sector. Harris and Ullman, 1945, provided an innovative description that analyzes the spatial structure of urban areas in the multiple nuclei theory. Many studies have been carried out on urban housing in both the developed and developing worlds. For instance, in recent times there has been an extraordinary revival of interest in the spatial preferences of households in choosing a residential location, especially in the urban area. In the more advanced countries of America, the United Kingdom and the eastern part of the world, several studies have examined the changes in the pattern of residential houses. Carney, 2006, Kearney and Erlomben, 2015, Nadiuk and Krivets, 2018, Premier. 2021. Also, studies have been conducted to unravel the spatial dimensions of neighborhood housing quality. Myung Jin, 2013, Hack et al. 2020. Furthermore, some studies have been conducted to examine the factors influencing housing quality. Swayce et al. 2014, Raji I and Mansourian, 2017, Ren et al. 2019. Besides, there are quite ample studies on livability in residential neighborhoods. Socio-Economic, 2015, Zonghua and Swejun, 2015, Satu and Chu, 2019. In the developing world, particularly Nigeria, several studies have been carried out on urban housing. Goff, 2000, Arco et al., 2011, Falali, 2012. Bear, 2014, Adewale and Adewale, 2017, Isiana, 2020. In recent times, there is a revitalization of interest in the spatial preferences of households in choosing residential locations within an urban environment. Fakunal et al., 2018. Moreover, studies have shown that residential neighborhoods exist in different patterns. Fazakan, 2018. Furthermore, studies have revealed that there are gross inequalities in the quality of residential housing units. Ogu, 2002, Mornikiji et al., 2017, Thomas and Hassan, 2018, Isiana, 2020. There are many studies on the poor environmental and health condition of slum areas and squatter settlements. Faithero and Ganiyu, 2010, Omol, 2010, Babalola et al., 2016. In addition, studies have been conducted on factors influencing housing quality. Yod et al., 2015, Yod et al., 2018. Also, several efforts have been made at documenting the characteristics and conditions of residential housing units in Nigerian urban centers. Salami, 2016. There are scanty studies on urban housing in Akure, where the present study was conducted. Omol, 2010. Assessed housing conditions and socio-economic lifestyles of slum dwellers in Akure, Nigeria. In another study, Fazakan et al., 2018, focused on the impacts of land pricing on the pattern of residential density in Akure. From the foregoing, it is obvious that while most of these studies only provided general views on housing, some others focused on just one particular aspect of urban housing. In other words, none of the existing studies on Akure has combined themes of urban housing quality and characteristics with the pattern of the residential neighborhood. Yet, this is a major policy issue that should not be underemphasized. Therefore, this study seeks to fill the gap in the emerging social spatial transformations by advancing knowledge on the physical structure and socio-economic characteristics of urban residential housing units in developing countries using Akure, Ondo State, Nigeria as a case study. Thus, this study assessed the relationship between housing quality and the socio-economic characteristics of residents in the study area. Also, the study examined environmental issues. Journal of Contemporary Urban Affairs, 6, 2, 217-231/2022. Dr. Adewale Mukhtar Olayiwola and Professor Dr. Olayinka Akinsumbo Ajala 219. Associated with people living in the study area. Furthermore, the study evaluated the resulting pattern of the residential neighborhood in the study area. These were with the view of offering explanations for sustainable housing delivery systems to improve living conditions in Nigerian urban centers. 2. The study area. The study was carried out in Akure, Ondo State, Nigeria. It lies between latitudes 7 degrees 07 N and 7 degrees 37 minutes north. and longitudes 5 degrees 06 E and 5 degrees 38 minutes east, Figure 1. Akure. With a land area of approximately 991 square kilometers, is the capital city of Ondo State with two local government areas, LGA, Akure South and Akure North. LGAs, Ibitoye Etal, 2017. The Aboriginal people are of the Yoruba tribe, though there are other tribes such as Igbira, Igbo, Edo, and Hausa. Among others, major economic activities include farming, trading, tourism, and civil service. Also, the inhabitants of Akure engage in scale indigenous industrial works such as cloth weaving, gari production, block and bakery activities, Eads. 1980, Daniel, 2015, Ondo State Ministry of Agriculture and Natural Resources, Osmanur, 2015. Ibitoye Etal, 2017. Figure 1. The study area. Sources, Landsat 8 Oli/Tier, 2021, Google Earth Map, 2021. Town Planning Division of Akure South Local Government Area. According to the National Population Commission of Nigeria, NPC, the population of Akure in the last national headcount conducted in 2006 was 353,211. NPC, 2006. Based on this census result, the population of the study area for the current year of study, 2021, was estimated using an official annual growth rate of 3.2% for urban centers in Nigeria. Nigeria Bureau of Statistics, NBS, 2021. However, because the population is compounded annually, the addition of annual growth rate, R, and 1, a constant that denotes the inclusion of the current year in the calculation, was raised to a power of the number of years for which the population was projected, T, and multiplied by the population of the base year, PO. The formula is given as follows. Equation 1. 1 equals 0, 1 plus 100. EQ1. Due to its latitudinal location, Akure experiences a tropical humid climate with two distinct seasons. Wet and dry seasons. The wet season starts in April and ends in October, spanning over 7 months. The total annual rainfall ranges between 1,300 mm and 1,650 mm, Ajala Etal, 2013, Osmanur. 2015. Temperature is generally high during the day, especially in March and April. The annual mean temperature is 29 degrees Celsius, while evaporation is usually low from June to September, 3.3 mm to 4.0 mm per day. Relative humidity ranges between 5% and 90% between the seasons. Ajala Etal. 2013. The vegetation of Akure is rainforest, consisting of valuable trees used for timber products, such as mahogany, obeche, iroko, and afara. However, the area is fast becoming a derived forest zone due to persistent clearance of the vegetation. The study area contains lowlands and rugged hills, between 315 m and 402 m above the mean sea. Journal of Contemporary Urban Affairs, 6, 2, 217-231/2022. Dr. Adewale Mukhtar Olayiwola and Professor Dr. Olayinka Akinsumbo Ajala 220. Level. While the northeastern part consists of basement complex rocks, the southern section comprises sand ridges, lagoons, swamps, and creeks. The soils are mostly tropical ferruginous with varied textures and gravel content. Ibitoye Etal. 2017. 3. Materials and methods. 3.1. Data sources. Data for the study were extracted from Landsat 8. Oli/Tier, Google Earth Map, Street Map of Akure, and Household Questionnaire, Table 1. Also, detailed personal observations were carried out, using handheld GPS for recording the location. Attributes of major landmarks in the study area. Table 1. Characteristics and sources of data. Notes. N/A, not applicable. Afrigist, African Regional Institute for Geospatial Information Science and Technology. OAU, Obafemi Awolowo University, Ile-Ife. The sample frame for this study includes all heads of households in the study area. In 2006 there were 89,263 households in Akure, NPC, 2006. However, there has not been another national headcount in Nigeria since 2006, therefore, the study used an estimated number of households based on the official annual growth rate of 3% for urban centers. In Nigeria, FBS, 2021. The compound interest formula was used to calculate the number of households for the current year of study, 2021, as contained in equation 2 equals 1 plus EQ2, where A equals number of households for the current year, 2021. P equals number of households in the last headcount, 2006, equals 89,263. R equals annual rate of increase, FBS, 2021, equals 3%, 0.03. N equals number of times the increase is compounded per year, equals 1. T equals number of years between the last headcount and the current year, equals 15 years. Applying the formula, the number of households in Akure in 2021 was 139,069. The appropriate sample for this study was determined using an online calculator, Creative Research Systems, sample size calculator. Thus, 383 out of the total 139,069 households in Akure in 2021 were selected for this study. A stratified sampling technique was adopted in the selection of residential housing units for the study. However, noting that there were variations in the quantity and concentration of buildings, the study area was categorized into 3 strata. I. High-density residential zone, HRZ. 2. Medium-density residential zone, MRZ. 3. Low-density residential zone, LRZ. Furthermore, using the online calculator with particular consideration for the differences in building clusters, the 383 samples were distributed among the 3 residential zones. Table 2. Table 2. Distribution of samples in the study area. S/N zone number of households. Sample size. 1. High, HRZ, 50,417 195. 2. Medium, MRZ, 45,021 119. 3. Low, LRZ, 39,581 69. Total 135, 019 383. 3.2. Data analysis. The study adopted a combined process of visual image interpretation and digital image processing to identify similar clusters of pixels that characterize the land use class of interest. Thus, following the supervised image classification procedure by adopting the maximum likelihood algorithm, the area was classified into 2 broad land uses/covers. I. Built-up area, all areas containing building structures. 2. Non-built-up area, this included vegetation, water body, and bare surfaces. The spatial accuracy assessment utilized included producer accuracy, PA, users accuracy, OA, and overall accuracy, OA, indices, Table 3. Also, kappa analysis was performed to ascertain the level of accuracy of image classification. Moreover, z-statistics were calculated to validate the reliability of the imagery accuracy assessment, Sinha, 2016. Data year resolution path/row source. Questionnaire 2021 N/A field survey. Township map of Akure 2016 N/A town planning, Akure South LGA. Shape files of Nigeria. Ondo State. Akure. 2021. 2021. 2021. N/A. 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 Afrigist, OAU. Ile Fet. Afrigist, OAU. Ile Fet. Afrigist, OAU. Ile Fet. Landsat 8 Oli/Tier March 6, 2021 28.5 M190/055 http://glcf.umiax.um.edu. Google Earth Map, Akure accessed. September 10, 2021. N/A. Population Data 2006 N/A NPC, Nigeria. GPS Coordinate 2021 N/A Ground Truthing. Journal of Contemporary Urban Affairs, 6, 2, 217-231/2022. Dr. Adewale Mukhtar Olayiwola and Professor Dr. Olayinka Akinsumbo Ajala 221. Table 3. Distribution of validation points, by LULC. S/N. LULC class. No of points. Topographical map. Google Earth map. Ground points. 1. Built up 284655. 2. Non-built up 355560. Total 63101 115. To vividly describe the pattern of the residential neighborhood in the study area, features of interest such as major roads and the built-up area were digitized in Google Earth and saved as KML files for further processing in ArcGIS. The converted layers were then overlaid on a Google Earth map of Akure, where on-screen digitizing was employed to extract the built-up area and streets. Using the Google Earth map complemented with the ground truthing, the densities of the buildings were digitized to classify the study area into 3 residential zones: high density, medium density, and low density residential zones. The first step in the analysis of data obtained through the questionnaire involved the identification of parameters and variables for assessment. 2 parameters were involved in the analysis: the socio-economic status of respondents and the quality of buildings. Table 4. Table 4. Parameters and variables for assessment. S/N parameters variables tag. 1. Socio-economic, N equals 6. Age x1. Gender x2. Marital status x3. Level of education x4. Occupation x5. Average income x6. 2. Housing quality, N equals 11. House type y1. Floor y2. Wall y3. Painting y4. Roof y5. Ceiling y6. Water y7. Toilet y8. Waste y9. Electricity y10. Fence Y11. Data obtained through the questionnaire were analyzed using percentages and mean, which were used to assess the socio-economic characteristics of heads of households in Akure, and to evaluate the characteristics and quality of housing units in Akure. The relationship between socio-economic status and the quality of buildings occupied by respondents in the study area was determined using Pearson correlation coefficient, equation 3. The purpose of the Pearson correlation coefficient, denoted by R and also known as Pearson product moment correlation coefficient, is to determine the relationship between two quantitative variables and the degree to which the two variables coincide with each another. In this study, the Pearson correlation coefficient was employed to measure the linear relationship between socio-economic status and the quality of buildings in the study area. Equals XX X X 2 2 EQ3, where X equals socio-economic characteristics of respondents. X 16 Table 4 equals the quality of the building. 111 Table 4. In Pearson correlation coefficient, the correlation is strong or high if R is plus or minus 0.50 less than or equal to plus or minus 1, moderate degree if RR is plus or minus 0.30 less than or equal to plus or minus 0.49, and low, or small, correlation when the value lies below plus 0.29. Housing quality was derived by finding the average of the mean values of 111. Equation 4. Y equals 1 plus 2 plus 11 slash n EQ4. Journal of Contemporary Urban Affairs, 6, 2, 217-231/2022. Dr. Adewale Mukhtar Olayiwola and Professor Dr. Olayinka Akinsumbo Ajala 222. Therefore, the variance of housing quality was derived by finding the average of the variance values of 111. Equation 5. Y equals 1 plus 2 plus 11 slash n EQ5. 4. Results and discussion. 4.1. Image analysis. This section contains the results of image analysis, such as classification into land use/cover classes, area statistics calculation, accuracy assessment, and extraction of the built-up class. 4.1.1. General land cover of the study area. For this analysis, the land use and land cover, LULC, in the study area were classified into two broad classes, built-up and non-built-up areas, Table 5. While the non-built-up area covered just about a quarter of the total land area, 26.9%, the built-up covered 73.1%, Table 5. Table 5. Image reclassification. Sources: Landsat Oli/TIRS 2021, Path 190 Row 55. Figure 2 shows the spatial occurrence and area extent of the two classified land covers in Akure in 2021. The built-up was found in almost every part of the study area. Although the built-up area has spread to almost every part of Akure, there were still patches of non-built-up portions in the city. At this stage, Akure can be described as a fully developed urban center in 2021. Figure 2. General land cover of Akure, 2021. 4.1.2. Results of accuracy assessment. Results of the image classification accuracy assessment indicate that the producer's accuracy, PA, equals 97.66, the user's accuracy, UA, equals 100.00, and the overall accuracy, OA, was 99.74%, Table 6. Kappa analysis was 0.9237 and Z statistic yielded 44.08. These values indicate that there were significant agreements between the validation points and the extracted classes, Zanon et al. 2019. Table 6. Imagery classification and accuracy assessment. Sources: Landsat OLI/TIRS 2021, Path 190 Row 55. Note: PA equals producer's accuracy, UA equals user's accuracy, OA equals overall accuracy. Class name area covered. km superscript 2% of total land area. Built up 724.4273.1. Non-built up 266.58 26.9. Total 991 100. Class name land area. km superscript 2% of total land area. PA UA. Build up 724.4273.1 97.66 100.00. Non-build up 266.58 26.9 93.09 99.87. Total 991 100. Overall accuracy equals 99.74%. Kappa statistics equals 0.9237. Z statistics equals 44.08. Journal of Contemporary Urban Affairs, 6, 217-231/2022. Dr. Adewale Mukhtar Olayiwola and Professor Dr. Olayinka Akinsumbo Ajala 223. 4.2. The built-up area of Akure. The built-up area comprises residential quarters, business premises, and public utility buildings. Residential quarters provide accommodation for the human being, they are where man lives. Business premises are areas of commerce and economic activities. The business premises also include areas of industrial activities, whether local, indigenous, or modern. Public utility buildings are such areas that provide a common palace for community/township activities. Among such public buildings are the King's Palace, Town Hall, places of worship, churches and mosques, all day open, market system, police station as well as educational and health institutions. Figure 3 shows the spatial occurrence and the extent of the built-up area of Akure in 2021. The built-up area occupied an area of 724.42 square kilometers, 73.11%, spread to every part of the study area. Figure 3. The built-up area of Akure, 2021. Source: Landsat 8 OLI/TIR, 2021. 4.2.1. Pattern of the residential neighborhood. The residential neighborhood includes all areas occupied by residential buildings. These buildings were found in every part of the study area. However, the heaviest density was in the central part of the study area where the development impulses were more concentrated. Public utility buildings like the palace, town hall, many places of worship, churches and mosques, all day open, market system and oldest buildings in the city were found to form circular rings around Urakale, Ijasan, Oba Adazida Road, and CMS areas of the settlement. Figure 4. Asides from this concentration, sporadic developments dotted some areas in the northern and eastern parts of the study area. The pattern exhibited by the built-up area in the central part was found to be following the concentric zonation pattern identified by Burgess in 1925, Figure 4. Housing developments were found to follow the axial corridors created by the roads. This is most noticeable along Akure Benin, Akure Adu Akiti, Akure Ondo, and Akure Ilsa roads, figure 4. Thus, this encouraged the development of a linear pattern of growth similar to Hoyt's sectorial pattern. Hoyt, 1939. Journal of Contemporary Urban Affairs, 6, 2, 217-231/2022. Dr. Adewale Mukhtar Olayiwola and Professor Dr. Olayinka Akinsumbo Ajala 224. Figure 4. Pattern of residential neighborhood in Akure. 4.3. Socio-economic characteristics of respondents. The average monthly income of respondents was based on a threshold of $3,000, $66.67, which was the minimum labor wage in the country at the time of this study. Respondents in the area were well educated, with only 13.8% without any formal education. Also, the majority of the respondents were gainfully employed, only 11.5% were either students or unemployed. However, at the zonal level of analysis, there were some internal disparities in the socio-economic characteristics of respondents. For instance, whereas primary and secondary education were mostly favored in the HRZ, secondary and tertiary education were more prominent in the other zones. Also, in the HRZ and MRZ, trading and craftsmanship were the major human occupations, while civil service and trading were the most attractive occupations in the LRZ. Though, income distribution appears to be similar across the three zones, the point of departure was in the spread of middle-high income, 200,001. $444.44, 500,000, $1,111.11, the majority of whom were found in the LRZ, Table 7. Table 7. Socio-economic characteristics of respondents. Tag. Characteristics. Residential zones total. High, medium, low. N%, 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 N%. X1 age. 18 to 40 years. 41-65 years. Above 65. Total. 31. 86. 78. 195. 15.9. 44.1. 40.0. 100. 26. 54. 39. 119. 21.8. 45.4. 32.8. 100. 9. 23. 37. 69. 13.1. 33.3. 53.6. 100. 66. 163. 154. 383. 17.2. 42.6. 40.2. 100. X2 gender. Male. Female. Total. 122. 73. 195. 62.6. 37.4. 100. 78. 41. 119. 65.5. 34.5. 100. 51. 18. 69. 73.9. 26.1. 100. 251. 132. 383. 65.5. 34.5. 100. X3 marital status. Married. Single. Divorced. widowed. Total. 88. 36. 24. 47. 195. 45.1. 18.5. 12.3. 24.1. 100. 76. 20. 8. 15. 119. 63.9. 16.8. 6.7. 12.6. 100. 36. 27. 4. 2. 69. 52.2. 39.1. 5.8. 2.9. 100. 200. 83. 36. 64. 383. 52.2. 21.7. 9.4. 16.7. 100. Ilsa. Road. Ondo Road. Oyemican. RD. Oak. Ianu. St. Oak. Ijabu. Road. Oak. Arrow. St. Oda. Road. Oba. Isle Road. Oba Adazida. RD. Iwarakog Besa. St. Ijapo. Estate. Road. Benin RD. Adu. Ikiti. RD. 2.502.51.25 km. Legend. Akure. Road. High Density Zone. Medium Density Zone. Low Density Zone. Journal of Contemporary Urban Affairs, 6, 2, 217-231/2022. Dr. Adewale Mukhtar Olayiwola and Professor Dr. Olayinka Akinsumbo Ajala 225. X4 Level of Education. No formal education. Primary education. Secondary education. Tertiary education. Total. 32. 51. 74. 38. 195. 16.4. 26.2. 37.9. 19.5. 100. 13. 28. 42. 36. 119. 10.9. 23.5. 35.3. 30.3. 100. 8. 4. 21. 36. 69. 11.6. 5.8. 30.4. 52.2. 100. 53. 83. 137. 110. 383. 13.8. 21.7. 35.8. 28.7. 100. X5 Occupation. Civil service. Self-employed/craftsmanship. Trading. Others. Unemployed. Total. 14. 65. 72. 21. 23. 195. 7.2. 33.3. 36.9. 10.8. 11.8. 100. 21. 39. 30. 16. 13. 119. 17.6. 32.8. 25.2. 13.4. 10.9. 100. 31. 7. 12. 11. 8. 69. 44.9. 10.1, 17.4, 15.9, 11.6, 100, 66, 111, 114, 48, 44, 383, 17.2, 29.0, 29.8, 12.5, 11.5, 100. X6 average monthly income $1,111.11. Total 48, 82, 34, 28, 3, 195, 24.6, 42.1, 17.4, 14.4, 1.5, 100, 34, 31, 22, 23, 9, 119, 28.6, 26.0, 18.5, 19.3, 7.6, 100, 10, 8, 21, 24, 6, 69, 14.5, 11.6, 30.4, 34.8, 8.7, 100, 92, 121, 77, 75, 19, 383, 24.0, 31.6, 20.1, 19.6, 4.7, 100. Source: Field Research, 2021. Notes: The official minimum wage in Nigeria was $3,000, $66.67 per month. Conversion was based on a conversion rate of 450 to $1 as of September 2021. 4.4. Quality and characteristics of residential houses. The most common types of residential housing units in the study area were of the traditional type. 50.1%. Modern flat buildings and duplexes were more common in the low residential area. Materials used for flooring indicated that modern techniques were not yet fully adopted in the study area. Concrete or cement flooring styles still predominates in Akure at an average of 50.9% with the highest proportion found in the high-density residential zone. 66.2%. Modern and fashionable flooring styles were not fully adopted, while only 44.6% were tilled. Just 3.4% used terrazzo materials, Table 8. However, standard roofing and ceiling materials were being gradually accepted in the area. Asbestos ceiling 50.1%, plastic POP 24.5%, carved POP 22.5%. Results indicated that 67.1% of the sampled houses were fully plastered. However, internal variations between the zones reveal that 75.9% in the high density zone and 71.0% in the low density zone were fully plastered. This contrasted the situation in the medium density zone where only 50.4% were fully plastered. None of the buildings was with mud walls. Table 8. Table 8. Quality and characteristics of residential buildings in Akure. Tag. Materials used for construction. Residential zones total. High, medium, low. N%, 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 N%. Y1 house type. Traditional compound, bungalow. Traditional compound, story building. Traditional compound, mixed. Bungalow, flat. Story building, multi-flat. Duplex. Total 84, 43, 9, 32, 21, 6, 195, 43.1, 22.1, 4.6, 16.4, 10.8, 3.1, 100, 16, 27, 5, 41, 16, 14, 119, 13.4, 22.7, 4.2, 34.5, 13.4, 11.8, 100, 7, 15, 0, 18, 6, 23, 69, 10.1, 21.7, 0.0, 26.1, 8.7, 33.3, 100, 107, 85, 14, 91, 43, 43, 383, 27.9, 22.2, 3.7, 23.8, 11.2, 11.2, 100. Y2 flooring. Mud or earth. Concrete/cement. Tiles. Terrazzo/granolithic. Total. 3. 129. 62. 1. 195. 1.5. 66.2. 31.8. 0.5. 100. 0. 62. 51. 6. 119. 0.0. 52.1. 42.9. 5.0. 100. 1. 4. 58. 6. 69. 1.4. 5.8. 84.1. 8.7. 100. 4. 195. 171. 13. 383. 1.0. 50.9. 44.6. 3.4. 100. Y3 walling. Mud only. Plastered mud. Clay bricks. Concrete blocks. Plastered concrete blocks. Total. 3. 16. 7. 21. 148. 195. 1.5. 8.2. 3.6. 10.8. 75.9. 100. 0. 9. 16. 34. 60. 119. 0.0. 7.6. 13.4. 28.6. 50.4. 100. 1. 2. 12. 5. 49. 69. 1.4. 2.9. 17.4. 7.2. 71.0. 100. 4. 27. 35. 60. 257. 383. 1.0. 7.0. 9.1. 15.7. 67.1. 100. Journal of Contemporary Urban Affairs, 6, 2, 217-231/2022. Dr. Adewale Mukhtar Olayiwola and Professor Dr. Olayinka Akinsumbo Ajala 226. Y4 roofing. Asbestos sheets, ADEX. Concrete deck. Zinc. Roofing tiles. Total. 10. 8. 175. 2. 195. 5.1. 4.1. 89.7. 1.0. 100. 2. 13. 96. 8. 119. 1.7. 10.9. 80.7. 6.7. 100. 2. 7. 25. 35. 69. 2.9. 10.1. 36.2. 50.7. 100. 14. 28. 296. 45. 383. 3.7. 7.3. 77.3. 11.7. 100. Y5 ceiling materials. Asbestos. Concrete. Carved POP. Plastic POP. Total. 110. 8. 19. 58. 195. 56.4. 4.1. 9.7. 29.7. 100. 59. 3. 36. 21. 119. 49.6. 2.5. 30.3. 17.6. 100. 23. 0. 31. 15. 69. 33.3. 0.0. 44.9. 21.7. 100. 192. 11. 86. 94. 383. 50.1. 2.9. 22.5. 24.5. 100. Y6 painting. Entire building. Inside only. Outside only. Not painted. Others. Total. 76. 32. 1. 64. 22. 195. 39.0. 16.4. 0.5. 32.8. 11.3. 100. 52. 21. 3. 41. 2. 119. 43.7. 17.6. 2.5. 34.5. 1.7. 100. 42. 13. 1. 9. 4. 69. 60.9. 18.8. 1.4. 13.0. 5.8. 100. 170. 66. 5. 114. 28. 383. 44.4. 17.2. 1.3. 29.8. 7.3. 100. Y7 water sources, main source. Borehole. Well. River/stream. Public water service. Total. 39. 103. 0. 53. 195. 20.0. 52.8. 0.0. 27.2. 100. 37. 64. 1. 17. 119. 31.1. 53.8. 0.8. 14.3. 100. 43. 19. 1. 6. 69. 62.3. 27.5. 1.4. 8.7. 100. 119. 186. 2. 76. 383. 31.1. 48.6. 0.5. 19.8. 100. Y8 toilet facility. Water system. Pit. Bush. River/stream. Public toilet. Total. 110. 29. 0. 0. 56. 195. 56.4. 14.9. 0.0. 0.0. 28.7. 100. 71. 31. 0. 1. 16. 119. 59.7. 26.0. 0.0. 0.8. 13.4. 100. 59. 4. 4. 1. 1. 69. 85.5. 5.8. 5.8. 1.4. 1.4. 100. 240. 64. 4. 2. 73. 383. 62.7. 16.7. 1.0. 0.5. 19.1. 100. Y9 electricity, main source. Public. Generator. Solar/inverter. Others, candles, lanterns, rechargeable lamps. Total. 14. 153. 22. 6. 195. 7.2. 78.5. 11.3. 3.1. 100. 12. 69. 36. 2. 119. 10.1. 58.0. 30.3. 1.7. 100. 10. 28. 29. 2. 69. 14.5. 40.6. 42.0. 100. 36. 250. 87. 10. 383. 9.4. 65.3. 22.7. 2.6. 100. Y9 security fence. Full. Part. None. Total. 61. 14. 120. 195. 31.3. 7.2. 61.5. 100. 68. 23. 28. 119. 57.1. 19.3. 23.5. 100. 49. 13. 7. 69. 71.0. 18.8. 10.1. 100. 178. 50. 155. 383. 46.5. 13.1. 40.5. 100. Y10 Waste Disposal. Containers/bags. Open dump site. Gutter. Public dustbin. Private collector. Burning. Landfilling. Stream. Total. 27. 33. 7. 72. 31. 19. 4. 2. 195. 13.8. 16.9. 3.6. 36.9. 15.9. 9.7. 2.1. 1.0. 100. 21. 12. 1. 59. 14. 5. 7. 0. 119. 17.6. 10.1. 0.8. 49.6. 11.8. 4.2. 5.9. 0.0. 100. 8. 1. 2. 21. 27. 7. 2. 1. 69. 11.6. 1.4. 2.9. 30.4. 39.1. 10.1. 2.9. 1.4. 100. 56. 46. 10. 152. 72. 31. 13. 3. 383. 14.6. 12.0. 2.6. 39.7. 18.8. 8.1. 3.4. 0.8. 100. Source: Field Research, 2021. 4.5. Correlation between socio-economic characteristics and house quality. Results of coefficients of correlation between socio-economic characteristics of respondents and house quality at the level of the residential zone in Akure, Nigeria indicated that there were high correlations between house quality and level of education, R equals 0.99, in the high and medium density residential zones, Table 9. In the low density residential zone, only occupation had a significant relationship with housing quality, R equals 0.60. There were inverse correlations between housing quality and average monthly income, minus 0.454, and marital status, minus 0.689. Journal of Contemporary Urban Affairs, 6, 2, 217-231/2022. Dr. Adewale Mukhtar Olayiwola and Professor Dr. Olayinka Akinsumbo Ajala 227. Table 9. Correlation between socio-economic characteristics and housing quality, by zone. House quality. Age, gender, level of education, occupation, average annual income. Marital status. High density residential zone. Housing 1.000. Age 0.6131.000. Gender 0.338 0.796 Level of education 0.993 0.871 0.678 1.000. Occupation 0.428. 0.813 0.769 0.813 1.000. Average annual income 0.978. 0.886 0.750 0.919 0.797 1.000. Marital status 0.868. 0.9090, 0.9260, 0.8050, 0.077, 0.952. 1.000. Medium density residential zone. Housing 1.000. Age 0.736, 1.000. Gender 0.695, 0.698, 1.000. Level of education 0.900, 0.901, 0.767, 1.000, 0.334. Occupation 0.313. 0.924, 0.879, 0.334, 1.000. Average annual income minus 0.454. 0.906, 0.805, minus 0.285, minus 0.904, 1.000. Marital status minus 0.689. 0.898, 0.967, minus 0.909, minus 0.573, 0.374. 1.000. Low density residential zone. Housing 1.000. Age 0.922, 1.000. Gender 0.426, 0.817, 1.000. Level of education 0.408, 0.913, 0.678, 1.000. Occupation 0.601. 0.877, 0.769, 0.442, 1.000. Average annual income 0.470. 0.968, 0.750, 0.129, 0.508, 1.000. Marital status 0.366. 0.997, 0.914, 0.997, minus 0.464, minus 0.154. 1.000. Source: Field Research, 2021. At the level of the entire city, results indicate that all the socio-economic characteristics considered have a high correlation with the quality of residential housing units occupied by the respondents. Level of education with a correlation coefficient of 0.588 has the weakest correlation with housing quality in the study area. Table 10. Table 10. Aggregate correlation of housing quality and socio-economic factors. House quality, age, gender, level of education, occupation, average annual income, marital status. High density residential zone. Housing 1.000. Age 0.613, 1.000. Gender 0.338, 0.796, 1.000. Level of education 0.993, 0.871, 0.678, 1.000. Occupation 0.428. 0.813, 0.769, 0.813, 1.000. Average annual income 0.978. 0.886, 0.750, 0.919, 0.797, 1.000. Marital status 0.868. 0.909, 0.926, 0.805, 0.077, 0.952. 1.000. Source: Field Research, 2021. 4.6. Discussion. The socio-economic variables considered in this study spread across all works of life. The high similarity of some of the socio-economic characteristics considered among the three residential zones in the study area indicates that the population in the study was of homogeneous characteristics. Results of the general land use/cover analysis through Landsat imageries show that more than half, 55.1%, of the total land in the study area had been built up. Though there were sporadic developments in other parts, there was a remarkable expansion of the built-up area in the central part. This corroborates the findings of other studies that residential land accounts for the largest proportion of total urban land uses in many African. Journal of Contemporary Urban Affairs, 6, 2, 217-231/2022. Dr. Adewale Mukhtar Olayiwola and Professor Dr. Olayinka Akinsumbo Ajala 228. Cities, Coker et al., 2008, Arco et al., 2011, Isiana. 2020. Like Ogu, 2002, this study identified 3 residential zones in the study area based on building densities: high density, medium density, and high density zones. The high density zone is the core area of the city where the oldest buildings are found. This is where the settlement started. The zone lacks planning controls and there was a very little touch of modern technology in the housing standards. However, some of the buildings have been either renovated or reconstructed, particularly along the major roads. This zone houses the largest share of the business and economic activities in the city. Therefore, the area was swarming with a large population, and of course the attendant noisy environment. In the medium-density residential zone, there were traces of the introduction of new waves of development. The houses were of better quality than in the old core of the city. The majority of the inhabitants of this zone were average income earners who were able to own a house or afford to pay the house rent. This zone contains more roads, most of which lead outwards from the city. Thus, in place of the concentric pattern formed in the high density zone, foundations for the sectorial pattern were laid in the medium density area. The low density residential zone was a bit more orderly with sophisticated building materials than other zones. In agreement with Jiboyi, 2010, housing facilities in this zone were found to be better and more sufficient than in the other zones. Residential houses in this zone agree with the description of some earlier studies that housing is not just a shelter, because it includes all the social services and utilities that make a neighborhood a habitable setting. Carney, 2006, Adewale et al., 2014, Burkinick, 2017. The observed variations in the quality and characteristics across the different residential zones in Akure might not be unconnected with the educational levels and type of occupation of the inhabitants. See Table 7. Considering the settlement at large, though mud walls and earth surfaced floors are fast disappearing in the study area, the result indicates that the level of technology of building construction in the area was still at a rudimentary level. 5. Conclusion. This study has shed some light on the quality and condition of residential housing in Akure, especially in terms of adequacy of basic housing utilities as well as relationships between the socio-economic characteristics of residents and the quality of buildings occupied in Akure, Nigeria. Results of the study have revealed that there were differential relationships between house quality and the socio-economic characteristics of respondents across the 3 residential zones in Akure, Nigeria. 4. Instance, there were high correlations between house quality and level of education in the high and medium density residential zones. In the low density residential zone, only occupation had a noteworthy relationship with housing quality. However, there were inverse correlations between housing quality and an average monthly income as well as marital status in all the zones. Moreover, the study observed that inadequate housing facilities are fundamental to the observed deteriorating housing qualities in the study area. Therefore, the study recommends as follows. First, for sustainable housing delivery in the study area, house owners should be educated on the relationship between essential housing facilities and the health of the inhabitants. This will encourage property owners to accept any bylaws that may be enacted to induce housing providers to provide certain basic services in their houses. Second, noting that poor housing quality is linked with low income, poverty alleviation programs should be improved to reduce the unemployment rate in the country, which will enhance the provision for basic household facilities and proper maintenance of buildings. Moreover, there is a need for a renewal program through a renovation approach and the construction of more roads to open the devastated areas. Although few concepts of housing quality were explored in this study, it makes some relevant contributions to the existing body of knowledge on housing research. It has shed some light on the opinions of residents on the quality and condition of housing in Akure, Nigeria. Also, the study has successfully employed remote sensing and geographical information system techniques to evaluate the pattern and quality of residential housing units which did previously not exist in the study area. In addition to this, the study has incorporated housing patterns and housing quality in just one research, which is very infrequent. Furthermore, the findings of the study, through the statistical analysis of the correlation between the socio-economic characteristics of respondents and house quality, have provided a set of specific factors enhancing house quality and characteristics in the study area. Nonetheless, one major policy implication that can be drawn from the findings of this study is that adequate and effective measures to ensure residential land use development control should be introduced. Therefore, it is hoped that the findings of this study will provide a sufficient basis for policy attention on housing improvements in major urban centers in the country. The evaluated concepts can serve as a basis for further studies on housing quality assessment. Also, this study can be used as a Journal of Contemporary Urban Affairs, 6, 2, 217-231/2022. Dr. Adewale Mukhtar Olayiwola and Professor Dr. Olayinka Akinsumbo Ajala 229. Foundation for the evaluation of other sets of valuable criteria for analyzing the characteristics and quality of residential housing. Acknowledgements. The author gratefully acknowledges the support from the African Regional Institute for Geospatial Information Science and Technology, Afrigest. Obafemi Awolowo University, Ile-Ife, for providing relevant and necessary materials required for carrying out this study. Also, the author thanks the anonymous reviewers for their insightful comments and valuable suggestions. Funding. This research did not receive any specific grant from funding agencies in the public, commercial, or not-for-profit sectors. Conflicts of interests. The author declared that there was no conflict of interest relating to the conduct, outcome, and publication of this study. Data availability statement. Raw data were generated from remotely sensed data. Derived data supporting the findings of this study are available from the corresponding author. AM on request. Ethics statements. Studies involving animal subjects, no animal studies, are presented in this manuscript. Studies involving human subjects, no human studies are presented in this manuscript. Inclusion of identifiable human data, no potentially identifiable human images or data is presented in this study. Credit author statement. Conceptualization, AM, OA. Data curation, AM, OA. Formal analysis, AM, OA. Funding. Acquisition, no funding investigation, AM, OA. Methodology, AM, OA. Project administration, AM. Writing original draft, AM. Writing review and editing, AM, OA. Both authors have read and agreed to the published version of the manuscript. References: Adewale, FM, and Adewale, MBO. 2017. Factors influencing housing characteristics in Lagos peripheral settlements, Case of Akure, Architecture Research, 7, 5. 191 to 200 https://doi.org/10.5923/j.arch20170705.01. Adewale, AO, Aziz, OT, and Yusuf, OI. 2014. Perception of housing quality by residents and non-residents of Ibera Housing Estate, Abeokuta, Ogun State, Nigeria. American Journal of Human Ecology, 3, 35-42. https://doi.org/10.1163/216796221504586. Arkuji, Lujinai, and Nganda IRP. 2011. Housing and Health in Contrasting Neighborhoods in Accra, Ghana, Journal of Social Science and Medicine. 72, 11, 1864-1872. https://doi.org/10.1016/j.sox/simed.2011.03.023. Asuwaju YA, Olabode, FO, Duvbiama, OA. Iyamu, JO, Adeyemo, AA, and Anigbinda, MT. 2013. Hydrochemical evaluation of groundwater in Akure area, southwestern Nigeria, for irrigation purpose. European International Journal of Science and Technology, 2, 8, 235-249. Online. https://east.org.uk/images/frontimages/gallery/volume_2_8/21.pdf. Accessed, September 26, 2021. Babalola, O.D., Ibom, E.O., Olojuaho, A.O., and Fulani, O. A. 2016. Residents' Perception of Quality of Public Housing in Lagos, Nigeria. International Journal of Applied Environmental Sciences, 11, 2, 583-598. Online. https://core.ac.uk/download/pdf/791243117.pdf. Accessed, September 26, 2021. Bear, W.C. 2014. Using Housing Quality to Track Change in the Standard of Living and Poverty for 17th Century London. Historical Methods, A Journal of Quantitative and Interdisciplinary History, 47, 1, 1. 18 https://doi.org/10.1080/016154440.2013.800801. Perkinick, I. 2017. Housing Quality Assessment Criteria. Electronic Journal of the Faculty of Civil Engineering Aussie EGFOS, 8, 14, 37 to 47. https://doi.org/10.13167/2017.14.5. Burgess, E.W. 1925. The City, Suggestions for Investigation of Human Behavior in the Urban Environment. Chicago, University of Chicago Press. Coker, A., Awakla, O., Olamolei, P., and Booth, C. 2008. Challenges of Urban Housing Quality and its Associations with Neighborhoods Environments. Insights and Experiences of Ibadan City, Nigeria. Journal of Environmental Health Research, 7, 1, 21. 30. Creative Research Systems. Sample Size Calculator. Online, https://www.surveysystem.com/scalp.htm. Accessed, September 16, 2021. Daniel, O.A. 2015. Urban Extreme Weather, a Challenge. For a Healthy Living Environment in Akure, Ondo State, Nigeria. Climate, 3, 4, 775 to 791. https://doi.org/10.3390/CLI3040775. Eads, J.S. 1980. The Yoruba Today, Changing Culture. Series. Cambridge, Cambridge University Press. Isiana, U. 2020. Quality Housing, Perception and Insights of People in Benin City, Nigeria. Urban Forum, 32, 1, 87 to 110. https://doi.org/10.1007/S12132-020-09409-1. Journal of Contemporary Urban Affairs, 6, 2, 217-231/2022. Dr. Adewale Mukhtar Olayiwola and Professor Dr. Olayinka Akinsumbo Ajala 230. Faithero, G., and Ganiu, S. 2010. Effects of Flooding on the Built Environment in Akure, Nigeria. In S. Laria. RTF. Learinger, and W. Hughes, eds. Proceedings of the West Africa Built Environment Research Weber, Conference, Accra, Ghana, 281-287, July 27 to 28, 2010. Fakunal, A. Ogundare, J. Olayinka Ali, L. Mayowa. Aradegbe, M. Bello, T. Ilujolo, O. and Saliu, OOA. 2018. Housing Quality and Risk Factors Associated with Respiratory Health Conditions in Nigeria. In A. Al-Musad, and A. Amsad, eds. Housing. In Tech Open. https://doi.org/10.5772/intech-open.78543. Faizakan, J.O., Basarun, J.O., Bello, M.O., Enison, O.F. Oho, B., and Popola, O.O. 2018. Effect of Land Pricing on Residential Density Pattern in Akure, Nigeria. Advances in Social Sciences Research. Journal, 5, 1, 31-43. https://doi.org/10.14738/asrj.51.4003. Falali, R. 2012. Housing Conditions in Tunisia, the Quantity-Quality Mismatch. Journal of Housing and the Built Environment, 27, 3, 317-347. https://doi.org/10.1007/S10901-012-9271Z. Nadiuk, O., and Krivets, O. 2018. Post-Soviet residential neighborhoods in 2 second-order Ukrainian cities. Factors and models of spatial transformation. Geographica Pano NICA, 22, 2, 104. 120 https://doi.org/10.5937/22-17037. Goff, KV, and Yang Sun, PW. 2000. Land markets in African cities, the case of peri-urban Accra, Ghana. Urban Studies, 37, 13, 2485-2500. https://doi.org/10.1080/00420980020080651. Hack, I, Rana, MJ, and Patel, PP. 2020. Location matters, unraveling the spatial dimensions of neighborhood-level housing quality in Kolkata, India. Habitat International, 99, 102,157. https://doi.org/10.1016/j.habitat.2020.102157. Harris, C.D., and Ullman, E.L. 1945. The Nature of Cities. The Annals of the American Academy of Political and Social Sciences, 242, 1, 717. https://doi.org/10.1177/0002716245242000103. Hoyt, H. 1939. The Structure and Growth of Residential Neighborhoods in American Cities. Washington. Federal Housing Administration. HSU, CI, and GUO, SP. 2006. CBD-oriented commuters. End mode and residential location choices in an urban area with surface streets and rail transit lines. Journal of Urban Planning and Development, 132, 4. 235-246 https://doi.org/10.1061/ASCE 0733 9488 2006 132:4 235. Ibitoy Mo, Adarai Big Bog, Adigboyega SA, and Adewale AO. 2017. Spatio-temporal analysis of land surface temperature variations in the rapidly developing Akure and its environs, southwestern Nigeria using Landsat data. Ethiopian Journal of Environmental Studies and Management 10, 3, 389. 403 https://doi.org/10.4314/egesm.v10 i3.9. Jiboyi, A.D. 2010. Post-occupancy evaluation of residential satisfaction in Lagos, Nigeria, feedback for residential improvement. Frontiers of Architectural Research, 1, 3, 236-243. https://doi.org/10.1016/j.4.2012.08.001. Jocham, W.C., Bird, T.J., and Tatum, A.J. 2018. Identifying residential neighborhood types from settlement points in a machine learning approach. Computers, Environment and Urban Systems, 69, 104-113. https://doi.org/10.1016/j.compenverbsib.2018.01.004. Carney, A. 2006. Residential Development Patterns and Neighborhood Satisfaction Impacts of Density and Nearby Nature. Environment and Behavior, 38, 1. 112 to 139 https://doi.org/10.1177/00139165052777607. Kanadu Ajyemeng, K. 2001. A Survey of Housing Conditions and Characteristics in Accra, an African City. Habitat International, 25, 1, 1534. https://doi.org/10.1016/S01973975, 00-00016-3. Kerniati, R., and Erlomban, Fr. 2015. Changes the pattern of residential space into commercial space in Chinatown Semarang. Prostia Environmental Sciences, 23, 307 to 314. https://doi.org/10.1016/j.proenv.2015.01.045. Mornikiji, W., Domaru, E., Pi, H, Gia, S, Idowu, O, and Adewale, B.M. 2017. Spatial Analysis of Housing Quality in Nigeria. International Journal of Sustainable Built Environment, 6, 2, 309 to 316. https://doi.org/10.1016/j.ijsb.2017.03.008. Myung Jin, J. 2013. The Effects of Housing Preference for an Apartment on Residential Location Choice in Seoul, A. Random Bidding Land Use Simulation Approach. Land Use Policy, 35, 395 to 405. https://doi.org/10.1016/j.landjacpol.2013.06.011. National Bureau of Statistics, 2021. Demographic Statistics Bulletin. Nigeria, Abuja, Demographic Statistics Division. National Population Commission of Nigeria, 2006. 2006. National Population Census Results. Abuja, National Office of Statistics. Ogvi. 2002. Urban Residential Satisfaction and the Planning Implication in a Developing World Context. The Example of Benin City, Nigeria, International Planning Studies, 7, 37 to 53. https://doi.org/10.1080/135634702201125999. Omol KF. 2010. An Assessment of Housing Condition and Socio-Economic Lifestyles of Slum Dwellers in Akure, Nigeria. Contemporary Management Research. 6, 4, 272 to 290. https://doi.org/10.7903/cmr.2980. Journal of Contemporary Urban Affairs, 6, 2, 217-231/2022. Dr. Adewale Mukhtar Olayiwola and Professor Dr. Olayinka Akinsumbo Ajala 231. Ondo State Government, 2015. Ondo State Ministry of Agriculture and Natural Resources, Osmanur. Akure, Government Press. OOEE, J. and Ogundiran, A. 2014. A Study on Housing and Environmental Quality of Moniya Community in Ibadan, Nigeria. Journal of Environment and Earth Science, 4, 13, 51 to 60. Online. https://core.ac.uk/download/pdf/234663526.pdf. Accessed, September 28, 2021. Page, IC. And Gordon, G. 2017. What is quality in buildings? New Zealand, Brands Ltd. Premier, A. 2021. Developing place attachment in high-density residential neighborhoods in China. Comparing the role of shared outdoor environments in two residential models in Qingdao. Sustainable Cities and Landscapes, University of Auckland, 1-10. Raji, S.A., and Mansourian, H. 2017. Urban Growth and Housing Quality in Iran. Social Indicators. Research, 131, 587 to 605. https://doi.org/10.1007/S11205-016-1260-2. Ren, H. Yuan, N. And Hu, H. 2019. Housing Quality and Its Determinants in Rural China, a Structural Equation. Model Analysis. Journal of Housing and the Built Environment, 34, 1, 313-329. https://doi.org/10.1007/S10901-018-9629Y. Salami, KK. 2016. Housing Facilities and Realities of Health of the Elderly in Nigerian Cities. Nigerian Journal of Economics and Social Studies, 58, 1, 53-75. Online. https://www.resetarchgate.net/publication/330987051. Accessed, March 16, 2022. Satu, S.A., and Chu, R.L. 2019. Livability in Dense Residential Neighborhoods of Dhaka. Housing Studies, 34, 3, 538-559. https://doi.org/10.1080/026730337.2017.13647111. Sinha, P., Verma, N.K., and A.L., E. 2016. Urban Built Up Area Extraction and Change Detection of Automa. Municipal Area using Time Series Landsat. Images. International Journal of Advanced Remote Sensing and GIS, 5, 8, 1886-1895. https://doi.org/10.23953/cloud.ajarsk.67. Stray Imakin, D. 2015. Quality of Life and Housing. International Journal of Information and Education Technology, 5, 2, 140-145. https://doi.org/10.7763/ija@.2015.v5.491. Swayze, R.J., Shanak, R.O., L. Sayman, A.A., and Sufan, T. 2014. Factors Affecting Quality in the Jordanian Housing Sector. International J of Housing Markets. An Analysis, 7, 175-188. https://doi.org/10.1108/IJMA01-2013-0004. Thomas, O.S. and Hassan, O.A. 2018. Assessment of Factors Influencing Housing Quality in the Coastal Community. International Journal of Innovation and Sustainability, 2, 1-8. Online SSRN. https://ssrn.com/abstract=3138142. Accessed February 13, 2022. Wimale Sina, N.N., Chong Richards, A., Wang, K. and Dirks, K. 2022. Housing Quality Indicators, A. Systematic Review. In, Sandanayak, YG, Gunatilake. S. And Waityasakara, KGAS. eds. Proceedings of the 10th World Construction Symposium, pages 531 to 544. June, 2022, Sri Lanka. https://doi.org/10.31705/WCS.2022.43. Yod, AO, Adeyemi, OO, and Adeyemi, BB. 2015. An Assessment of Housing and Neighborhood Quality. Condition in Ilsa, Nigeria. Analele Universitatai. Oradya, Syria Geography, 25, 242-252. Online. http://istgeoRLent.uoradya.ro/reviste/anali/anali.htm. Accessed, February 13, 2022. Yod, A, Adeyemi, O, and Yod, O. 2018. Assessment of Housing Quality in Ada, Nigeria. Asian Themes in Social Sciences Research, 1, 2, 7683. https://doi.org/10.33094/journal.139.2018.12.76.83. Zainal, N.R., Kar, G., Ahmed, N.A., and Khalili, J.M. 2012. Housing Conditions and Quality of Life of the Urban Poor in Malaysia. Prostia Social and Behavioral Sciences, 50, 827-838. https://doi.org/10.1016/j.spspro.2012.08.085. Zanon, S., Kayegaro, N., and Albatasai, R. 2019. A Novel. Approach for the Definition of an Integrated Visual Quality Index for Residential Buildings. Applied Sciences, 9, 8, 1579. https://doi.org/10.3390/app908159. Zonghua, H., and Swejun, D. 2015. Assessment and Determinants of Residential Satisfaction with Public Housing in Hangzhou, China. Habitat International, 47. 218-230. https://doi.org/10.1016/j.habitat.2015.01.025. How to cite this article. Olayiwola, A.M., and Ajala, O.A. 2022. Correlation between socio-economic characteristics and housing quality of residential neighborhoods in Akure, southwest Nigeria. Journal of Contemporary Urban Affairs, 6, 217-231. https://doi.org/10.25034/ijqa.2022.v6n2-8.